Today's video is going to be putting it all together, meaning when I have a problem where I need to simplify using more than one rule. How do we go about doing that? Before we start, I want to remind you that you are learning this from home. Be easy on yourselves. This standard is actually also in the algebra curriculum, so every student taking pre-algebra this year will also cover these exponent rules next year, so you'll be taught it again. You won't be expected to completely understand it walking into your math classroom freshman year. So the three things to keep in mind putting it all together: one, it doesn't matter the order that you apply the rules. You can divide first, you can multiply first, you can distribute first. It does not matter. The next thing to keep in mind is we can never have a negative exponent in our final answer. We need to make all of those exponents happy. And the last thing to keep in mind is we're going to simplify as much as possible, meaning we're not going to leave 5 squared in our answer. We're going to change it to 25. So if you are following along at home in your notes, this is the page 3 from the notes yesterday. And here we go, lost it there for a second. So it's the last page on the exponent rules notes. It's titled Putting It All Together, and there are 8 problems for us to go over today. So for this one here, we did one just like this in the last video. We know that the rule states when I have an exponent on the outside of parentheses, it goes into every piece in there. So this would leave me with 5 squared n squared. And just like I said before, I cannot leave that. I need to simplify it because I do know the value of 5 squared. 5 squared is 25. So my final answer here is going to be 25 n squared. Next problem looks almost the same, except now I have a fraction in there and I have a power raised to a power. So that's not just 1 anymore. For this, my 3 is going to go into that fraction of a half, and the 3 goes to that m cubed. Well, I know a half to the power of 3 means a half times a half times a half. Another way to think about that too, that you could also apply this rule, is the 3 also touches the 2. So 2 times 2 times 2 is 8. So you can think about that in either way. No matter which way you end up doing it out or kind of thinking about it, you're going to end up with 1/8. 1/2 to the power of 3 is 1/8. And I know when I raise a power to a power, I multiply. That's the rule we learned yesterday. So I have 1/8 m to the power of 9, because 3 times 3 is 9. Now you can write it this way. This technically goes in the numerator, so if you wanted to write it, some kids would end up writing this just like this. These two mean the same exact thing. It doesn't matter which way you choose. The next problem we're going to be using our division rule. I have a squared b cubed c to the 8th divided by a to the 7th b, remember we're going to add that 1 in there, to the first power, c to the 3rd. So I'm going to match up my letters and I end up subtracting. So here I have 2 minus 7, so I have a to the power of -5. 3 minus 1 is 2, so I have b squared. 8 minus 3 is 5, so c to the 5th. Now there's something wrong with this. Remember, one of those things we needed to remember from the beginning. We cannot leave a negative exponent in our final answer. Remember, the negative rule tells me that when I have a negative exponent, I need to move it to the opposite side of the fraction bar. Here I'm going to move it down. So I'm going to move that a to the power of -5. I'm moving it to the basement. Now he's happy. So I have b squared, c to the 5th, over a to the 5th. I cannot simplify this anymore because none of my bases match. I can't do anything else here. We'd be done. This next rule, the thing that I said to remember in the beginning about applying different rules at different times, and it doesn't matter the order, that comes into play here. I prefer to deal with all the negatives first. You could also add your division rules in here. I like to get rid of all the negatives first. That's just how I go about doing it. So first thing I would do before I even do that is simplify this. So 24 over 48, that can change to a half. So I'm done with that. The next piece, I don't want to deal with that negative in the basement anymore. I'm going to move it up top and make it happy. So m squared, and I like to cross off as I go. In the top, I still have m to the power of 6. We're not moving that anywhere. We're only moving negative exponents. And n to the 8th can stay there, and n to the 3rd can stay down the bottom. Now, when you get comfortable with these, you might kind of skip writing out every single step, but I'm writing it for you so you can follow along. So n to the 8th over n to the 3rd, we know we multiply when we're dividing. And here, when we're multiplying, we add. So I know how to simplify both of those right now. I have 1/2, I know that out front. And when I combine the m's, m squared times m to the power of 6, that means I add the exponents, so I have an 8. And I subtract when I'm dividing, so I have n to the power of 5. So you can leave your answer like that, put that in the middle, or you can write it out. You don't need that 1 there if you didn't want it. You can just write it like this. Those two things mean the same thing. Sorry for the glare. Those mean the same thing, and you would be done with that problem. We are halfway done. We have 4 left here. For this one, I have a lot of multiplication going on, and like I said before, when I have negative exponents, I like to just make them happy right off the bat. I like to turn them positive. So I'm going to go through this. This is technically a multiplication. It's all multiplying together. I'm going to keep anything with a positive exponent in my numerator, and anything that's a negative exponent, I'm going to move it to the denominator to turn it happy. So here my 5 is positive. Technically there's a 1 there if I wanted to put that. I'm going to keep the 5 up top. X to the power of -2, not happy, needs to move to the basement, down to the denominator. Y to the power of 1, that's fine where it is. I'm going to keep that up top. And z to the power of -3, not happy, down to the basement. There is nothing else you can do for this problem. I have no matching bases. That is simplified as possible. You would be done. Next one, I have a big division problem this time, and again, I like to stick with making my negatives positive first. So the first thing I'm going to do, if this were me doing this problem, I would move this up top to make that happy, and then I'm not dealing with negatives anymore. So I have 2 times x to the 3rd up top. I'm moving that 3, x to the power of -2, I'm moving that up and making it positive. And that x to the 5th is staying right where it is. It's happy there. When I come to this though, how I have it written out now, I see that I can simplify these. These are able to be simplified because I have the same base. Both bases are x, and I know when I'm dividing something with the same base, that means I'm going to subtract my exponents. So for this one, I have a 2 on top. When I do 3 minus 5, oh bummer, look what happened. I have a negative exponent again that I'm going to need to deal with, and I still have a 3 squared up top. Come over here, this is all still multiplying by each other. I need to move that negative exponent down below. So I'm going to even come over here more. I'm going to keep my 2 right where it is. I'm going to keep my 3 squared right where it is. Those are fine. I'm only moving the negatives. That negative's going to move down, and I change it positive because now it's happy. And I've done all my rules except for I know the value of 2. I know the value of 3 squared. 3 squared is 9. Do that right away. And I know 2 times 9 is 18. Big smudge. So I'd have 18 over x squared for that one. All right, here we go for this one. This one, I have a parenthesis. I have 3x to the power of -2, y, z cubed, all to the power of 2. That's a lot. When I have parentheses with an exponent outside of it, I like to put that in first. So I'm kind of going away from that negative like I told you before, and I'm going to put that 2 into everything before I do anything else. So when I do this, I'm actually just going to do it in red. It might be easier to see. The 2 is going into everything. So I'm going to put the 2 onto the 3. I do 2 times -2 to get -4. That 2 is going to go into the y. And 2 goes into the 3. Remember, I'm multiplying when I have an exponent to the power of an exponent. So I'm going to have a 6 here. 3 times 2 is 6. Got rid of that. Technically, you don't need the parentheses anymore. So let's get rid of those as well. Now I'm going to keep everything that's happy on top and move that term here that's not happy. I'm going to move that to the basement. And I know 3 squared is 9. I'll take care of that now as I rewrite it. Did that. I know x to the power of -4 is not happy. That's going to go to the basement, and now they're happy. Y squared can stay on top, already a positive exponent, and z to the power of 6 can stay on top because it's already a positive exponent. And you would be done there. This next one, kids look at often a problem like this and get really confused, like why do we have parentheses? you don't need them. So I sometimes say to just rewrite it with the multiplication dots in between, and I think that clears it up for some kids. These two things mean the exact same thing, no matter which way you write it. And I'm gonna add a 1 onto that Z. So this one in black and this one in red, they mean the same thing. I like to rewrite it like that when I teach it. I think it clears things up. And now I'm just gonna combine based on matching bases. So I'm gonna take my just numbers, my constants, and I have 2 and 4. Well, 2 times 4 is 8. And I'm gonna cross those off that I used them already. Next, I'm gonna do the x's. I have x squared times x to the power of -5. Remember, when I'm multiplying, I add. So 2 plus -5 is -3. Cross those off because I used them. Next, I added the 1 on my z. I did not add it to the y, so I'm going to put that in now. I'm going to combine the y's. I have y to the power of 1 times y cubed. That means I'm adding those exponents. Y to the power of 4. Cross them off. And last but not least, I'm left with a z. There's no one to pair them up with, so it's just going to stay z to the first. Now, one more thing, I have to remember I can't leave a negative in my final answer, so the only thing I have left to do here is move that x to the -3rd down into the denominator. So I'm going to keep 8, y to the 4th. I'm just going to write z, you don't even need that 1. And I'm going to put x to the 3rd. When I move it down, it's now happy. That would be my final answer. So hopefully that cleared up some confusion for you guys. Hopefully, if there was any left there, that's applying all the rules in one. It is a lot. Keep that in mind. Again, be easy on yourselves. Come to the Zooms, in the forms that you fill out when you watch the notes, when you leave a question there. We will get back to you right away when we see it. So if you have any questions, please leave it there. Reach out. We're here to help, and we're happy to help. And we miss you. Hopefully we'll see you soon in a Zoom. Bye-bye.